So a shape can also have rotational symmetry as well as line symmetry. And if we take a look at this shape up here, this shape does indeed have rotational symmetry. Now when it comes to working out rotational symmetry, all we do is envisage that shape rotating, and it's a full 360 degrees, a full turn that it rotates. And we see how many times the shape would look like the original state as we take it on that 360 degree journey. Now if we rotate it, the first time it looks like itself would be after 90 degrees. It would fit exactly on itself and look like it does here. The second time would be when we got to 180 degrees. Then at 270 degrees, and then the final time it would look like itself would be once we completed that 360 degree turn. So in the course of the 360 degree turn, it has fitted on itself 4 times. So we would say here that if we rotate the shape 360 degrees, it has a rotational symmetry of order 4. Now the other thing you need to be able to do is to actually rotate the shape yourself. And they will ask you, potentially in a question, how many lines of rotational symmetry a shape has, and it may be the best way for you to do it is to actually use the tracing paper that's provided to you in the exam in order to work it out yourself. So we're going to go back again to another practical example to show you how to use tracing paper to identify the order of rotational symmetry of a given shape. So we've seen how rotational symmetry works, but I wanted to show you a couple of examples about how you can use tracing paper to help you calculate the rotational order of symmetry of something. Now tracing paper is supplied to you in the exam, and it's something that's very useful to help you work out some of these graphical questions. So let's look at the first shape I've been given, and they want to know what the order of rotational symmetry is for this shape. Now you may be able to tell by looking at it what it is. After all, it does have 4 spokes coming off of it. But when you want to check using tracing paper about the order of rotational symmetry, this is how you do it. Take your piece of tracing paper and place it over the shape they've given you. Mark on the centre of the shape. And also, it's very helpful to just do a quick sketch outline of the shape. Now this doesn't have to be perfect because you're not actually being scored on your ability to trace around the shape. We're merely using it as a guide to work out the order of rotational symmetry. So I've traced over the shape, and I'm now going to mark one of my boxes with an X. This is not only going to help show us when we have the same shape within a turn, but also when we've done the full 360 turn. The next thing, I put the point of my pencil right in the centre of the shape. And now what I'm going to do is to just rotate my tracing paper around that centre point. Now you see, as I start to rotate my paper, I arrive at the same shape after 90 degrees. So I know it already has order of at least 1. If I continue rotating, I get the same shape again. If I continue once more, and then I know I've reached my final 360 because my X is back at the top of the shape where I did it originally. So therefore, I made the same shape 4 times in the 360 degree turn. So what I would say about this shape is that it has order 4 rotational symmetry. Now, our next shape is a parallelogram. But just because it has 4 sides, it doesn't mean it has a rotational symmetry of order 4. We're going to use our tracing paper again. Once more, place it over the shape and just do a rough sketch of the shape itself. Now you should always be able to spot the centre of any shape, and you can see that our centre point here is bang there in the middle. Again, I'm going to mark with a cross, this time one of the corners of the shape. I'll mark this one here, just so I know how far I've turned and how many times it's fitted upon itself. Just as before, I place the point of my pencil on the centre and begin my rotation. Now you see I don't actually create the same shape until I've turned it 180 degrees. And there I've created another parallelogram the same size. Continuing my turn until I've done it one full 360 degree, which is back where I started, and you'll see that it fitted upon itself twice in that 360 degree turn. So the order for this particular shape would be order 2. The final shape we'll look at is a kite. Now you can see when we rotate this shape 360 degrees, at no point does it fit back on itself and give us the same shape. In this case, we would say that the shape has no rotational symmetry. Alternatively, we can say that it has rotational symmetry of order 1.